All right, taking a look at 6.2. All right, 6.2 works on starting to create these ratios, creating these proportions, and finding your pieces that are true. All right, make your comparisons. So, it says you're building a scaled model of your house in math class. It says your actual house is 24 feet long and 18 feet tall. The model you are making is 18 inches long. First question says, how tall will it be? Now, some people will go through and say that you have two different units. They'll change their units, and by all means, that's perfectly fine. However, here's the nice thing about proportions. The key is be consistent. So when I go through to figure out how tall my model will be, right? If I want to compare 24 feet to 18 feet, that's perfectly fine. I am comparing how the length of my house to the height of the house. Then I got to compare length to height again. 18 inches long over X. When it comes to your units, as long as your units are consistent, you do not need to change it. If I compare feet to feet on the left, then I need to compare inches to inches on the right. And I do not need to convert. Right? Somebody else may have put a different proportion together. You could do 18 feet over 24 feet instead. Maybe you want to do the height over the length. That's fine as long as you do the height over the length again. Somebody else may do length to length and height to height. That's fine. If you do it that way, your proportion is going to be a little different also. And if you do length to length, you'd have 24 feet over 18 inches. Then I have to do height to height. I'd have to do 18 feet over my X inches. All of that is perfectly fine. All three of these, you'll get the same exact answer. So when we cross multiply here, right, let's take our first one for example, the blue one that's here. So we'll take a look at this proportion right here. If we cross multiply, we get 24x equals 18 times 18 is 324. When we divide, we get 13.5. Now remember, our x here, no matter which one we solved, our x was going to be in inches. Now, for our other one, for part B, it says how many times taller is your actual house compared to the model. Here is where your units will matter because we're just doing a direct comparison. We're looking at a ratio. How many times taller is your actual house? Well, our actual house was 18 feet tall compared to the model. Well, our model was 13.5 inches. Here's where we do need to convert. 18 feet is actually 216 inches. So our conversion then, we do 216 divided by 13.5, and we find out it is 16 times taller. Now, those three different proportions we can create, all three of them work because there are certain rules to our proportions. And that's what we're going to look at here today. We're going to look at these rules, and then I'll allow you to go through and start setting up those different pieces. All right. The first one is known as your cross product property. It's how you multiply and solve these proportions. It's called your cross product property because that's what we do. Right? It's how you solve those proportions. Right? It is cross multiplying. Now, your second one allows us to flip the side or flip the pieces we're comparing. Right? We said you can compare length to height, or you can compare height to length. It doesn't make a difference as long as you do it on each side. If two ratios are equal, then their reciprocals are also going to be equal. So if I flip the left-hand side, I have to flip the right-hand side. Our next one is going to be known as our interchanging means. Basically, it says that we can flop or flip the position of these two. It doesn't matter if I do B times C or C times B. It's not going to make a difference at all. So this is what basically allows us to say, okay, we can compare height to length and height to length, or you can compare height to height and length to length. It doesn't make a difference as long as you're consistent. That's the great thing about proportions. Now our last one then is known as our adding denominator. Right? This one really doesn't come up. We'll talk about it briefly, but it doesn't come up very naturally. Right? Basically what it says is I can add the bottom to the top of each side. So I can add my B to the top here, and I can add my D to the top here. And my proportion will still work out. Now we're only going to do all of these once, and then from then on out, you can do whichever one you want to create. So when we look at our first example, it says in our diagram, they give us that ratio to be true. It says write our 4 true proportions. So the first one we're just going to fill in as it sits. So AC is 12, DF is 18, BC is 9, EF is X. So there's our first proportion. Now, our second one was known as the reciprocal, which means if I take the reciprocal of the left-hand side, I must take the reciprocal of the right-hand side. Our third one was known as our interchanging means. It says that you can swap these two values. Instead of comparing the 12 to the 18, we can compare the 12 to the 9. As long as when we compare the 12 to the 9, then we got to do the 18 to the X. Notice all they did was flip-flop the numbers from the bottom left to the top right. Our last one then is known as your adding denominator. Basically saying that I can take this denominator and add it to the top here, take this denominator and add it to the top here. So that's 12 plus 18 over 18 equals 9 plus X over X. Those are your 4 true proportions. And then it says write our 4 true proportions. So there's all 4 of them. In B, I'm going to change the directions on us. Instead of writing all 4 of them, I don't care which one you create. I want you to solve for X. That's ultimately the goal, to go through and solve for X. So we'll fill it in. AB is 12. DE is 9. AC is 8. DF is X. Cross multiply, we get 12 times X is 12X. 9 times 8 is 72. And we divide. We get X to equal 6. Right. Take a look at example 2 then. So filling in our pieces here. JL. This is where we got to be careful. JL is not X. Right? The whole thing here, JH, is X. JL then is that whole X without this 2 on the bottom. So JL is X minus 2. LH is 2. JK is 15. KG is 5. And now we'll cross multiply. 2 times 15 is 30. X minus 2 times 5. Be careful, you need to make sure you distribute that 5 into both of those values. So we get 5x minus 10. So we add 10 to both sides. We have 40 equals 5x. And we divide by 5. We get x to equal 8. Now, they want to know how big JH is. JH was X. So JH is 8. JL is this piece here. That piece does not include that 2. So JL is 6. All right, take a look at our next one then. We got SV over VT. So SV is our 8 this time. VT, if the whole thing ST is X, and this top part here is 8, then V to T is X minus 8. SU is 12. UR is 28. Okay. Once again, we'll cross multiply. 8 times 28 is 224. 12 times X minus 8. What we are saying is we have 12 times that X minus 8. This is why we have to distribute that 12 in. So we have 224 equals 12X minus 96. So add your 96 to both sides. We get 320 equals 12X. And then we divide by 12. 320 divided by 12. We get 26.67. Now they want us to find ST and TV. ST, S to T is our whole length here. ST is X. So ST is 26.67. VT is just this bottom part. V to T does not include the 8. So we take the 8 off of it, and we get 18.67 for VT. Right, brings us to our next idea, which is called scale. What a scale drawing is, it is a drawing that represents the same shape as the object it represents. Right, it's a model car. Right, it's a model building. It's a blueprint. Now, the key is when you go to find your scale is a ratio that describes how the dimensions of a drawing are related to the actual dimensions of your object. To find scale, right, it's a ratio, so we're going to compare two things, something like 10 to 8. Now, typically in a ratio, you reduce that to 5 to 4. However, in a scale, it even gets reduced further. In a scale, it always reduces to something to 1. So to get my 4 down to 1, we'd have to divide by 4. That means I need to take my 5 and divide that by 4 also, giving me my answer of 1.25 to 1. In a scale, decimals are allowed. The key is that right-hand value. It is always going to be something to 1. That right-hand value has to be 1. Now it says the length of the key is 7 centimeters in a scale drawing. The length of the actual key is 4 centimeters. What is the scale of our drawing? To find our ratio of a scale, it is always your scale drawing to your actual object. So in this problem, we are going to have 7 to 4, the scale drawing to the actual object. To get it down to something to 1, I'm going to have to divide my 4 by 4, which means I have to divide my 7 by 4 also. So we get 1.75 to 1. Right, in your next one, it says a blueprint shows an MP3 player. The diameter of the round speaker of the blueprint is 0.4 inches. The actual length is 1.6 inches. What is the scale of our blueprint? So once again, we're going to have 0.4 to 1.6 this time. To get 1.6 down to 1, we got to divide it by 1.6. Which means I have to divide this side by 1.6 also. Which gives us our ratio of 0.25 to 1. All right, example 4 works with the finding those scales and using that scale drawing. In our first one, it says the scale of a map is 1 inch represents 8 miles. It says on the map, 2 towns are 1.25 inches apart. It says what is the actual distance between the towns? So once again, we are looking at these ratios and we are going to create that proportion. 1 inch goes to 8 miles. 1.25 inches is going to go to our X miles. Once again, we don't need to convert as long as we are consistent. On the left, I'm doing inches to miles. On the right, I'm doing inches to miles. So when we cross multiply here, we get X to equal 10. My X was represented in miles. So my answer is 10 miles. Looking at B then, it says the scale of a map is 2 inches represents 1,440 feet. It says find the actual distance of a street on this map if it measures 3 inches in the drawing. So now I got 2 inches. Represents 1,440 feet. I got 3 inches in my drawing. I got to figure out X is going to have to be, well, X will be in feet in this case. If I have inches over feet on the left, I need to have inches over feet on the right. Cross multiply 2 times X is 2X. 1,440 times 3 is 4,320. And then we'll divide both sides by 2. 4,320 divided by 2 gives me 2,160. And we said that unit was going to be in feet. Now our last 2 examples are going to be very similar to the opener that we did. In the first one, it says Phil buys a 3D scale model of his sun sphere. It says the actual building is 266 feet tall. His model is 20 inches tall. The diameter of the dome in his scale model is 5.6 inches. What is the diameter of the actual dome? And then how many times taller is the actual building compared to the model? So when we start, we're going to set up our proportion. 266 feet tall over 20 inches tall. So we're doing height to height. Then we're going to have to do diameter to diameter. Right now we have the height of the real building, the actual building on top. So we have to do the diameter of the actual building on top. Well, that's my X. The model goes on the bottom then, 5.6 inches. So here's our proportion to cross multiply. 266 times 5.6 gives me 1,489.6. 20 times X is exactly that, 20X. Divide both sides by 20, we get 74.48. So that is the height, that is the length of our actual dome, or the diameter of the dome. It's 74.48 feet. Now it says how many times taller is the actual building compared to the model? So this is where we're going to take our 266 feet tall divided by our 20 inches. So we do need to convert here. 266 feet is 3,192 inches. Divided by 20 We get 159.6 times taller. All right, last example in our notes then. Taking a look at the Sears Tower, it says imagine a 3D scale model of this Sears Tower. The actual height of the building, including the antenna on top, is 1,703. It says her model is 29.4 inches tall. So we're going to do height to height, including the 4.4 inch antenna. So then we're going to do antenna over antenna. Well, I don't know the height of the antenna of the actual building, but I know in the model it is 4.4 inches. So here's our proportion to solve. Once again, our units match up. I got feet over inches on the left, feet over inches on the right. So cross multiply here, 1,703 times by 4.4. We get 7,493.2. 29.4 times x is exactly that, 29.4x. So then we divide. We get x to equal 254.87. And my unit here would be in feet. So what's the height of the actual antenna? 254.87 feet. Now, as for the other question, how many times taller is the actual building, including the antenna, compared to the model? So I have my 1,703 feet divided by my 29.4 inches. Here we do need to convert. 1,703 times by 12 gives me 20,436 inches. So we take that, divided by my 29.4, and we get it to be 695.1 times taller. Right, which leads us into your homework here tonight. Right, please let me know if you have any questions.